Hi there, my name is Steve Hutman and I'm in MEC203 and this is my Razor drone design. How I came up with this design was a general interest in aviation and also in remote control airplanes and drones as well. I know that with my novice ability to fly said drones and airplanes, destroying my new investment is definitely a big part of how I came up with my design, and I'd say probably the pride of my design is in these bumpers here, which hopefully you can see my cursor surrounding them. The bumpers will help protect the aircraft as well as the propellers, which are a huge part of this aircraft. So transferring my ideas to a 3D model, we're simply just taking my own experiences and my own just experiences with flying different kinds of drones and what I liked and didn't like about them. So my design, I believe, I call it the Razor drone because it's very sleek, I think, which adds the performance as it's very aerodynamic. And also that paired with its lightweight construction leaves you with, I think, a great value, honestly. So at any rate, let's take a look at the motion study now. As you can see, the drone, the propellers are all spinning in unison, and they are all, yes, clearing the bumpers on the sides. So we can play that again, check it out. I'd like to next discuss the tolerances of my drone. So let me remove the top, and let's take a look first at my motors here. As you can hopefully see, there's a little bit of gap around the motor where the motor sits into its mount or its cylinder here, and the ID of the motor cylinder or the mount here is 29.78 millimeters, and the overall diameter of the motor 27.5. That leaves you about a meter on each side. The reason for that is this motor is inevitably going to produce heat, and I know that the heat needs to escape, and there will also be a gap around the motor shaft up top to allow that heat to hopefully escape through. And the reason there is such a great amount of clearance is the motor does not press fit in. It is held in by screws on the bottom. So now at any rate, in opposition to this is the propeller, which, like most DC hobby motors, the propeller normally press fits into place. So therefore the ID of the propeller hole is 3.17 millimeters, and the OD of the motor shaft is also 3.17 millimeters. And with a slight press fit, this thing should not go anywhere. Now, the battery cover, which is a very basic design, and it looks a lot like battery covers probably found on many of your remote controls for your televisions, or even your calculators, or your drones that you may own. Up top, there's a tab here that you will push down on, and with a slight interference fit, it will drag out. And then at the bottom here on the hinge, now the hinge shaft is 2.5 millimeters in diameter, and the inside diameter of the actual hinge itself here is 2.5 millimeters in diameter. So slight interference fit, and it should snap onto place, being that this is plastic. Okay, this hinge should flex, and once it's in place, because of its C shape, it will not fall off. So now I'd like to talk about, I guess, the pride and joy of my design, which will hopefully keep someone from destroying this thing, which is the bumper. The bumper now, this is just simply, this part here is the landing gear, and this will simply fit flush up against this here cylinder and screw into place up through the bottom. Now, right here is where there is no gap along this C-shaped part here. There's no interference there. There is, however, some interference here in this cylinder. The OD of the mounting screw cylinder for the motor mount cylinder, this area here, this overall diameter across here is 2.991 millimeters, and the ID of the receiver part of this is 2.984. So there is a slight interference fit there, and then of course a screw will go up through the bottom, fastening that into place. I hope you've enjoyed checking out my Razor drone design. I think it is a nice sleek design. And with the top back on, there it is. Thank you, folks.